So if we're asked to find the exact value of a logarithm or evaluate for a logarithm, sometimes I find it helpful. If you're trying to figure out what this logarithm is equal to, then make it a variable or make it a question mark. Sometimes it's easier when we're trying to rewrite and solve these things if we have something that we're kind of solving for. You guys are used to solving for something. So if we're saying log base 5 of 125 equals what, we're going to bring the 5 over and we're going to say 125 equals 5 to what power? Well, 5 cubed. So this whole logarithm is going to equal the value 3. So log base 5 of 125 equals 3. Log base what of 100? If there's no base, it is a base 10. So we're trying to figure out 10 to what power equals 100? Well, 10 to the second. All logarithms are used for is solving exponents. That's what they were used for. That's what they're created for. So that's what we're always solving for. We're solving for an exponent. So how about log base 5 of 1/5? What would that equal? So we're trying to figure out, okay, 1/5 equals 5 to what power? So whenever you guys are going from fraction to whole number or whole number to fraction, your exponent has to be negative. So really what you're looking at is 5 to what power would get you 5 because it's on the bottom of a fraction, it's in the denominator, it would have to be 5 to the negative first. Based off our exponent rules, that would get moved and you would have 1/5. So whenever you're going from fraction to whole number or whole number to fraction, that exponent has to be negative. That's the only way to do that. So number 7, log base 4 of 4 to the 6th. It looks more complicated than it is. What happens is if you have a log expression and an exponential expression with the same base, they're always going to cancel and we would be left with just 6. If I show you how we would write this or work it out, if you guys would bring this over, we would have 4 to the 6th power equals 4 to what power? Well, they have to be exactly the same. That question mark has to be just 6. So what happens, log expression, exponential expression with that same base are always going to just cancel out. And you're really just going to be left with that exponent. But if you rewrote it out correctly into exponential form, it kind of makes sense. Okay, if 4 to the 6th power has to equal 4 to something, if they're equal, they have to be the same value. So similarly here to number 8, the same thing's going to happen. But if you rewrote it, you would end up with 7 to the 4x equals 7 to what power? The 4x power. So that whole expression just simplifies or equals 4x. We said logarithm base e and natural log are inverses of one another. So same thing. These cancel each other out, but if you were to rewrite, natural log is a logarithm base e. So we have e to the 601 left on the left, and this would become e to what power? Has to be that number for them to be equal. Natural logarithm, logarithm base e cancel out, are inverses of each other. Okay, how about log base 8 of 2? So it's not a fraction, but we are going from a larger to a smaller number. We're trying to figure out 8 to what power gets us 2. So we have to think, how do 2 and 8 relate? Maybe you're thinking 2 times 4 equals 8, but we're trying to think of exponents here. So if we're thinking exponents, maybe we're thinking 2 to the third equals 8, but 8 to the third doesn't equal 2. If you're trying to go from a larger to a smaller, you would have to take the cube root of 8, right? Cube root of 8, I don't know why I wrote that on the left-hand side. The cube root of 8 equals 2. But how do we write that in exponential form? Well, you guys know. How would we write that in exponential form? 8 to the 1/3 equals 2, correct? So knowing how to get from one to the other is important, but then if we're talking about exponents, we need to know what that looks like in exponential form. So we could just rewrite that root as an exponent. And then number 11, log base 7 of the cube root of 7. Same thing goes, we're going to rewrite this in radical or in exponential form. So I'm going to first bring that or swing that 7 over. 7 to what power equals, I'm going to rewrite this as 7 to the 1/3. So this has to be 1/3 also. Logarithms are used to solve for exponents. So when you're evaluating a logarithm, you're really solving for the exponent of an expression.